All right, so let us now continue our discussion. So before we continue, do you guys have a concern or clarification? Hello?
No, sir.
Any question or concern before we continue?
None, sir.
All right. So if there is no question, then let's now continue. Okay. So we have here the inverse of relation using a diagram. Okay. So this is the original diagram. Okay. And then this is the inverse relation of a diagram. Okay. So we have 1A, 1B2, A2, B2, C, which is this one. And then the inverse of that one is the A1, B1, A2, B2, and then C2. So as you can see, our x coordinate became the y coordinate, and then our y coordinate became our x coordinate. Okay, so our domain became the range, range became the domain. Okay, so simple as that. Then you're good to go. All right, so are we clear so far regarding with this diagram?
Yes, sir.
How about the others? Or is it that only Mr. Maaba and Mr. Falawewa that I'm hearing to respond? Okay, so let me just check. Miss Rona Ramos? Right, so no response. So I guess she's not around. How about Mark Jason?
None, sir.
Okay, Mr. Kabuwag?
None, sir.
Okay, Mr. Gangas?
Gets naman, sir.
All right, how about Mr. Paran?
Wala din naman sir.
All right, how about Mr. Estalidia?
Gets none, sir.
Mr. Tanikala?
Gets naman, sir.
Okay, about Miss Grace? Miss Grace Ginran?
Yes, sir.
Okay, how about Miss Sekdigan?
Gets po, sir.
Okay, about Mr. Agustin?
Gets, sir.
Mr. Mendoza? So maybe she's not around. I mean, he's not around. How about Mr. Mark Jason?
Sir, it's naman po.
Okay, how about Mr. Alukan?
Gets po, sir.
All right. And then Mr. Kabuwag, I think I have already called you.
Sir.
All right. So again, if you guys have a question or any concern, so feel free to ask me or let me know your concern. Okay. So once you're done with those statics, then you may now start in answering the Seatwork number 4. Okay. So the relation R and the set 1, 2, 3, 4, 5 defined by the rule x, y is an element of R. Okay. So get all of the list of ordered pair, okay, and then find, or for each relation, find the inverse relation. Okay, so I should see two answer, the ordered pair and then the inverse relation of that ordered pair. Okay. So next one is composition of relation. So we have here O as a representation for composition. Okay, so it is denoted by R2. O, R1 is the relation from X to C defined by this kind of formula. So we have R2O, R1. wherein we have xy or xz as your element for R1, and then we have yw or zw as your element for the R2, then you should arrive at xw. Okay. All right, so let's have this example. We have the R1 and then the R2. So the question here is, what is R2 O R1? So just simply apply this formula and then you will get this answer. So from here, as you can see, we have 1, 2, and then 2u. Okay. So this one is actually quite similar with the implication or hypothetical syllogism or the transitive. So if we have 1, 2, and then 2u, you should have 1u. Okay. But instead of, in part of that relation, it is now in a form of R2 O R1. Okay. So you will come up with another relation. Okay. So this one now is your composition of relation of R2 over R1. Okay. So if you have 1, 2, and then 2u, you have 1u. What else? If you have 1, 6, and 60, you should have 1t, or you will get 1t. What else? You have 2, 4, and then 4s, you will get 2s. Okay, you have 2, 4, and then 4t, you will get 2t. Then what else? For 3, 4, and then 3, 3, 4, and then 4s, you will get 3s. 3, 4, and then 4t, you will get 3t. And then 3, 6, and then 60, you will get 3t. And then 3, 8, and then 8u, you will get 3u. Okay, so how did we come up with those ordered pair? So from this formula, which is the xw. Okay, so if you have xy and then yw, you should have xw. Okay, if you have xz and then zw, you should have zw. Okay, so let me just include it here, zw. All right. So are we clear so
Sir?
far?
I
Yes.
don't understand. XZ and ZW. That should also give us XW.
What? This one? XZ and
ZW.
ZW. Okay.
That should give us XW also.
XW. Yeah. Sorry. Thank you for that one, Mr. Falawebo. So this one is still the same. XW. XW. Yeah. Okay. So that is where I didn't include another one. So just this one, XW. XW. Yeah. Right? So did you guys get this one? Are we clear? Or is there a part that it's confusing you?
Clear, yes, sir.
Clear, sir.
All right. So again, when you say composition, you need two relations, and then just have this formula or apply this formula, then you will come up with xw or with this kind of answer. Okay. So once you're done with that topic, you're going to have, of course, a short safe work or activity. So we have here the R1 and then the R2. Okay, and then you should have the list of the element of R1O R2 and R2O R1. Right? So moving on, we have here the equivalence relation, okay, or the another type of order, call this one, order relation. So before we have the partial order, wherein we have the RAT, which is reflexive, antisymmetric, and then transitive. But right now, we have the equivalence relation, wherein it is reflexive, but it is now symmetric instead of antisymmetric, and it's still transitive. So for partial order, it is RAT or RAT, but for equivalence relation, we have here the RST, right? So those are their only difference. So same process. So you'll be given a set of relations, and then just check whether that one is reflexive, symmetric, and then transitive. if all of those three were able to met the condition, then you could say that this one is an equivalence relation. All right, so here's the solution for this example. We have the 1, 1 up to 4, 4. Okay, so as you can see, we have checked one by one. So this one is reflexive. Yes, we have 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. And then this one is also symmetric because we have 1, 3, 3, 1, 1, 5, 5, 1, and so on and so forth. Okay, and then this one also is transitive because we have the 1, 1, 1, 3, and we have the 1, 3, which is this one. Okay, so just check everything on all of those. Okay, transitive, symmetric, and then reflexive. If all of those are checked, then that one is an equivalence relation. Okay, so we will not discuss this one by one anymore because this one is quite similar with the partial order. It's just that instead of this one anti-symmetric, this one will become symmetric. Okay, so are we clear so far regarding with equivalence relation?
Yes, sir.
Yes, sir.
Yes po.
All right. Okay,
Yes,
so
sir.
that's good that some of you are now starting to respond. So once you're done with that example, okay, or partial order and equivalence relation example, so you may now start and answer this Seatwork number 6. So all you have to do is tell which of the following relations are equivalence relation or as equivalence relation. Okay, so again, when say equivalence, it's reflexive, symmetric, and then transitive. So we have 4 numbers for this one, right? And then recall set partition. So a collection S of non-empty subsets of X is said to be partition of the set X if every element in X belongs to exactly one member of S. Okay, so as you can see right here, we have an X having an elements of 1, 2, 3, 4, 5, 6, 7, 8. And then if this one has a one member under one set, okay, which is the same with this one. So we have 1, 4, 5, 2, 6, 3, and then 7, 8. And then as you can see, this one is under one set from this set. Then we could say that this set is a partition of that set. Okay, so you can see that S is a partition of X. Okay, well, the point in here is if we have this class, then all of them should be under one set, or should all of their elements should be found on the superset or this set X. Okay. So if you're going to take a look on this one is just with the use of this one Partition product. Okay, on every set. So we have 1, 1, we have 1, 4, we have 1, 5, we have 4, 4, we have 4, 1, 4, 4 only, and then we have 4, 5, and then we have 5, 5, and we have 4, 1, sorry. So it's just that they are shuffled. So we have 4, 1, and then we also have 5, 1, which is this one. Okay, and then we have 5, 4, and then 5, 5, of course. So as you can see, this one is the Cartesian product of itself. Okay, so if you're going to get the total numbers, okay, or total list of ordered pair, so just multiply it to itself. So 3 times 3, so you will get a total of 9 elements for this one, and then 2 times 2, so you will get a total of 4 elements for this one, and then 1 times 1 is still 1, and then 2 times 2 is 4. And then if you're going to add all of those, so 9 plus 4 is 13, plus 1 is 14, plus 2, plus 4 is 18, am I correct? 14 plus 4, 18. 9, 4 plus 4, 17, 18. Yeah, 18. So let's see if we have a total of 18 ordered pair. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 10, 11, 12, 13, 14, 15, 16, 17, 18. So all of those came from this set, okay, with the use of Cartesian product, right? Anyway, so this is just to say that this one is under a set of partition, or under a superset. Okay, so this one is a partition of that superset. Okay, so let's have another example for you to appreciate this one. So using a digraph, we have this 1, 3, 5, we have this 2, 6, and then we have this 4, right? So as you can see, using Cartesian product, you will have this reflexive, symmetric, and is it transitive? Transitive. If we have 3, 5, 3, 3. Yeah, it is also transitive. Okay. So anyway, once you have this list of elements, then you can now draw this one. Okay. So this is the digraph of this class 1, 3, 5, and then this is the digraph of this class, which is the 2, 6, and then we have this digraph of this 4, which is coming from the superset 1, 2, 3, 4, 5, 6. All right. So this is just a recall because we're going to be use this one later on. Okay, what is this class, this class, this class, and then this class? Okay, so let's move on with equivalence class, wherein our very main topic regarding with this set partition. So let R be an equivalence relation on a set X. So the sets A defined in set partition. So what is our set partition again? So this is an example of set partition. So where this one came from? This one came from our superset, which is this X. So for equivalence class, okay, so we will list all of the possible elements, okay, or all of the let's say student. Okay, so under class we have students. So we have this certain class 1, 3, 5, and then it has a student of 3 elements, or the 1, 3, and 5. And then for the second class we have 2, 6, and then of course it has a student of 2, which is the 2 and 6. And for the last one, under one class we only have one student, so we only have 1, 4. So 1, 3, 5, 2, 6, and then 4. So in this set partition, we have a total of 3 class, okay, and then each of them have a student. Okay, wherein this one has 3, has 2, and then has 1. So maybe right now you're quite confused on how we apply this equivalence class. So let's have another example. Okay, so given the following relation, R is equal to AA, BB, and then CC. So write the equivalence classes. Okay. So as you can see, this one is very obvious. Okay, so this is one class, another class, and then another class. Okay, so under this class, we have one element only, which is the A. Okay, and then another class wherein we have one element also, which is B, and then another class which is same element or same number of elements, which is one only, which is C. So second question is, how many equivalence classes are there in relation or in this relation? So you can say 3, since we have only formed 3 classes. Okay, so classes are divided by or this one separated by a comma. Okay. So just like this, we have 3 class in total. So can you guys follow now, at least a little, when it comes to classes?
Yes.
So,
Yes, sir.
All right. So at least need 50% of your understanding. So it's okay if you only understand 50%. Okay, so let's have another example. So how many equivalence classes are there in the following relation? So we have this relation. Okay, so all we need to do is check how many relations are there in, or how many classes, rather, not relation. How many classes are there in this relation? Okay, so listen carefully on this one. Okay, so from here, we have to check all of the distinct elements. Okay, so as you can see right here, we have one. Oops. We have one. We have two. We have three. We also have four. And then lastly, we have five. Okay. All right. So as you can see right here, we have 1, 1. So which is now this one. Okay. One element on that class. And then we also have 1, 3. So we could say that this one is a classmate of 3. Okay. So they are classmate under one class. Okay. And then what else? 1 is also related with 5. Okay, so we could say that 1 is also a classmate to element 5. What else? 1, 1, 1, 3, 1, 5. What about 1, 4? Do we have 1, 4? Okay, none. So as you can see right here, this is already one class, okay, having an elements of 1, 3, and then 5. Did I use the correct? Yeah, it's a curly bracket. All right. So this is already one class, 1, 3, and 5. Okay, because we have just find out that the classmates of 1 is 3 and then 5. Okay, so they are just under one class. How about 2? So 2 is also related with 3, so they are in the same class. How about 4? Yes, so they are also related in one class. 2, 4. What about 1? So we don't have 2, 1. So it doesn't matter what is the arrangement. So we can have 2, 4 or 4, 2. Okay, so they are just C. So as you can see right here, we have 2, 4, and then we have 4, 2. So you don't need to list the 4 or 2 here again. Okay, so you only need 1. Okay, so meaning they are related with each other already. Okay, how about 2, 5? Do we have 2, 5? Okay, so I guess none. Okay, so this is already one class having a set of our elements of 2, 3, and then 4. Oops, 3D bracket. And then for 3, so 3 is related with 1, 3 is also related with 5, and 3 is also related with 2. So 2 and 1. Oops. And then 5. What else? We have 3, 4. Okay, so we don't have 3, 4. So this is again another class. Okay, wherein we have 2, 1, 5. Okay, you have a question, Mr. Palawewa?
What about 3?
3? Sorry. 3 and then 5. Yeah. So thank you so much, Mr. Palawewa, for filling up my call this one missing information or lack of information. All right, so how about 4? 4 is related with 4, which is this one already. 4 is related with 2. And 4, we have 4, 1. We have 4, 5. So none. So from here, I could say that this is again another class wherein we only have 2 elements, which is 4 and then 2. Okay, how about 5? So 5 is related with 3. 5 is also related with 1. What else? Do we have 5, 2?
That's it.
5, 4, 9. Okay. That's it. So from here, this is again another class which is composed of element 5, 3, and 1. All right. So check everything. Okay. So it seems that everything is okay already. So once you're done in creating, okay, or coming up with the list of elements on every class, then you have to check whether there are the same classes. So as you can see right here, we have this one and this one. So they are just the same. And then again, since this one is a set, so arrangement doesn't matter. Okay. So the next question here is, or the question here is, how many equivalence classes are there in the following relation? So as you can see, this is one class, another class, and then another class. But in here, we can eliminate the another one already since we already have this one. So we only have a total of 1, 2, 3, 4 classes. 4 classes. So that's how we identify on how many classes are there in the following relations. So did you guys get this one so far?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Just look for the relations, okay, on each of ordered pair, and then make a list of it as a class like this one, and then check whether there is similar or the same elements. Then count how many classes we have in total. So in here we have a total of 4 classes. All right. How about example letter B? So we have here x 1 to 10, and then define x related to y if 3 divides x minus y. Okay, y here is already given, so we only have 1, 2, 3 as our y. And then as you can see, the numbers of x is 10, 7, 4, and 1 for this class. Okay, because that one is the condition that were met under this condition. So 10 minus 1 is 9, divided by 3 is a whole number. So 3 divided by 3 is 1. So 7 minus 1 is 6. So 6 divided by 3 is 2. And then 4 minus 1 is 3. So 3 divided by 3 is 1. And then 1 minus 1 is 0. So 0 divided by 3 is 0, okay, which is still a whole number. So as against right here, we just get the list of x under this condition. So the same with this one, list of x under this condition, and then list of x under this condition. So in total, we have come up with 3 classes. Okay. So 1, 4, 7, 10, 2, 5, 8, and then 3, 6, 10. So this is one class, another class, and then another class. Right? So are we clear so far regarding with this equivalence classes?
Yes, sir.
Yes, sir.
All right then. So again, you're going to have a Seatwork, of course. So we have this. So supposedly this one is letter A, and then this one's letter B, and then C. Or you can just ignore that one. Okay, just arrange that one using their alphabetical letters. So we have here A, B, C, D, E, F, G, and then A, B, C, D, E again. Okay, so just follow their order with alphabetical order. Okay, so for this one, determine whether the given relation is an equivalence relation on 1, 2, 3, 4, 5. So if the relation is an equivalence relation, list equivalence classes. Okay, so you should verify this one whether this one is a relation. under equivalence relation. Then if it's an equivalence relation, then list all the possible classes or list equivalence classes. Okay. So the same with B, C, and D. And then for this one, determine whether the given relation is an equivalence relation on 1, 2, 3, 4, 5. So if the relation equivalence is an equivalence, so this, yeah, they are just the same. Okay. But in here, since this one is already given as a relation or ordered pair relation, this one is not yet. So you're going to analyze this one first, the same with this one, letter B, and then come up with the list of relations and then its equivalence classes. So in here, it's like double steps or double solutions. Okay, so we have 4 numbers for this one. And for the last one is the members of the equivalence relations on 1, 2, 3, 4. Also find the equivalence classes of 1, 2, 3, and 4. Okay, so this one is the easiest part on this activity, since you know, all you have to do is list the members of equivalence relations. So just like what we did on this one. Okay, so any questions so far regarding with your Seatwork number 7?
Wala naman, sir.
Answer.
All right, so let's now move on to the next one, matrices. So this is already the last topic for this module. So matrices of relations. So a matrix is a convenient way to represent a relation from R from X to Y used by computer to analyze a relation. So we have here the row for the X and then Y or column for the Y. Okay. So if the set or if the entry on that X and Y is in relation with each other, or X is related to Y, then just put there 1. If they are not related with each other, or if they don't have any relation, then just put there 0. Okay, so let's have an example. So given the relation 1B, 1B, 2C3, C3B, 4A, and then we have these coordinates from X, 1, 2, 3, 4, and Y, we have A, B, C, D. So relative to the orderings 1, 2, 3, 4, and then A, B, C, D. So take note, your X here is the 1, 2, 3, 4, which is the rows. And then the Y here is the column, which is an arrangement of A, B, C, D, okay, which is this one. Okay, so just be wary when it comes to putting the format or arrangement. So for the column, it is the Y, and then for the rows, it is the X. Okay, so since right here we have 1B. So again, just look on the 1B coordinates and then just put there 1. So we have 1B, wherein they are in relation with each other. So just make this one 1. And then we have 1B. So just make this 1. And then we have 2C. So just make this 1 also. And then we have 3C. And then 3B. And then 4A. And then no more. Okay, so that's it. So for you to have an easier way of doing this one, so you can just leave the entire matrix blank for now, and then plot the relations. Okay, or the ordered pair wherein they are in relations. So make this one 1, 1, 1, 1, 1, and then once you're done in doing that one, then you can now fill up the rest by 0. Okay, so that's how we plot a relation or an ordered pair using a matrix relations or matrices of relations. So did you guys get this one so far?
Yes, sir.
Yes, sir.
All right. So again, we don't have enough time anymore. So we'll just continue the rest. So don't worry. It's now only 11 slides. So it maybe will only take 10 minutes more or less. So we'll just continue the rest on the part 4. Okay. So again, goodbye for now, and then just wait for the link of the part 4.